Okay, so let us start with the remaining part of our discussion, and the topic that we will be talking about is temperature, about which we have definitely certain ideas, and we will just recapitulate few things about it. So we'll talk about temperature, we'll talk about what it is defined for in what kind of systems, and we'll also talk about where thermodynamics recognizes the temperature as a concept, and then also we'll talk about different temperature scales, right? So as we said, the temperature is a property that is very important for any analysis of physical analysis of any physical system. So we need to realize that temperature is not defined for atoms and molecules, because you realize that when you studied quantum mechanical study of hydrogen atom, you never talked about temperature of that atom or any individual isolated molecule for that matter. So temperature is actually defined for bulk system, right? Bulk also we realize that bulk is where you have huge number of atoms and molecules of the order of say Avogadro number of particles, right? Also we must realize that temperature is actually defined for a system under equilibrium. So when the system is not under equilibrium, there also it is assumed that locally there are local equilibriums are assumed, and that's why for a system not under thermal equilibrium is also assigned a certain temperature in different regions of the system, assuming that in those regions there are local equilibrium that is maintained, and that is the way it is understood. Now we also realize that in thermodynamics, first the concept of temperature formally recognized through this zeroth law, right? That's why it is also, this law is referred also as temperature principle, because it recognizes that there is a property which is same for different bodies under thermal equilibrium, and this is the principle which actually helps us actually to build any thermometer or things like that. Apart from this, we also know how to measure temperature, and for that we have certain temperature scales. And broadly there are actually 4 types of temperature scales, out of which one of the most popular temperature scales is the Kelvin absolute temperature scale, or sometime it is also referred as ideal gas temperature scale, and that's why the PV equals to nRT has the T which is absolute temperature, and 1 degree Kelvin is equals to 1 degree centigrade. Apart from this absolute temperature scale, we have Celsius scale, and then Fahrenheit scale, and also there is not so popular, but there is a scale that is referred as Rankine scale, and in that Rankine scale 0 degree Kelvin is equal to 0 degree Rankine, but 1 degree Rankine is equated with 1 degree Fahrenheit. On the other hand, whereas in the case of 1 degree Kelvin, it is 1 degree centigrade. Okay, it will be also interesting if you can go back now to your previous thermodynamic classes or any thermodynamics book to realize that how second law of thermodynamics gives rise to this absolute temperature scale. So that will be very interesting. Another important aspect is that in this particular case, please note that this video I am making with another different software, so hopefully these videos will be little small, and I'll at a time I'll take only 2 slides so that it becomes smaller, and you do not have any problem to download them. So let me stop here, and the next video will follow.